Okay. Here doesn't matter. We were discussing about the case with the absorption under recoil. We'll proceed. Yeah. Here the mass perfect starts. Okay. Mass perfect. Even though some slides may looks with some kind of a repetitivity in the text, try to cooperate with me. Here, the initial reaction, particularly to the mass papers on gamma ray emission, ranged from disinterested to the doubt. See, if you say that we understood from our basic science, basic knowledge, or maybe from fundamentals of science, or we are calling that as a physicist, as we know. If somebody tells us that a theory or a concept or a phenomena which is not obeying our concepts, certainly we will disagree, no doubt. Or we may not show an interest to them on them during discussion part. Certainly we will doubt. As you leave a chalk from certain height or a stone from certain height, it falls down because of the gravity. No doubt. Okay. If it moves up, for example, by some means, oh, it's a great excitement actually. If such type of a phenomena exist, if that phenomena exists, rather than falling down, if it moves upward, okay, then we can say that something is acting against gravity, an anti-gravity phenomena, or it is overcoming the gravity and moving upward, or somebody is trying to pull it upward. We are calling it as a pull. You are not pushing from the down. If you are sending the rocket from the surface to the space, you are pushing it outward. You are giving the energy. You are supplying the energy. Forcefully, you are allowing the rocket to go up, leaving the Earth's gravity, or to leave the of Earth's gravity and to leave the planet either for encircling the Earth, or maybe it may go for the planetary systems, either to the moon or to the other systems or to the sun or to the other galaxies. Doesn't matter. But if somebody is attracting out, if you throw a ball will come back, because if nobody is there to catch it up, actually it will come back. Easiest way to tell like jokes. But it should not be a case for the physicist. To make the physicist to convince is a tough task. It is not an easier job. If something is there to attract, for example, if you throw, why can't you expect that moon will attract a ball? Why can't you expect that moon will attract a stone? Why can't you expect that moon will attract something like that? As in fact, even the moon is at about 384,000 or 3.84 lakh kilometer, roughly 4 lakh kilometer. Assume that an object, if you are thrown, reaches the gravitational sphere of the moon, certainly moon attracts. Moon attracts. And the stone or the object, the celestial body will be within the influence of that. Somebody is coming from extraterrestrial, that is not from the earth actually, will be attracted towards the earth mainly because of the gravity, means that type of things. Means here also, what he told that were initial reactions of the Mossbauer papers, but that is Mossbauer research papers on gamma ray emissions, which were emitted by an object or a target, is having a resonance. Certainly there is resonance, but he mentioned that there is no recoil at all. Means recoil-less nuclear resonance experiment. People have have not shown an interest or had doubted the work. In fact, according to the one of the widely repeated story which were published in German at that time, two physicists at the Los Alamos Scientific Laboratory made a 5 cent bet, maybe a 5 rupee or 500 rupee, what you can call right now, at that about 75 years back, about 5 cent bet on whether or not Mossbauer effect really existed. Yeah, true. If you are telling something like that, you will bet it. I will challenge that it will not happen. The person who has witnessed it will say that no, it is happening. Actually, I am sure of it. I have seen it. I witnessed it. It is convinced me. Whatever you thought is not the right. It can lie. But the entire world will not believe it. Actually, I will tell another incident here in this case when one scientist was in fact able to demonstrate the effect. The scientific community gained the interest. In the sense, one person explained, one person demonstrated the Mossbauer effect, and he won. There is no doubt after showing that something is done. Maybe if I request, it is my humble request actually, rather than amusement park and other things, all of you try to go to planetarium once or twice, where at least minimum once, and you also visit the museum next to that actually in Bangalore. It is a great museum actually, Jawaharlal Nehru Museum of that kind, and you witness several museums of scientific origin where you will learn a lot, where they will show so many demonstrations where you may not believe it. In the museums and things which are happening actually, where if you are unable to believe it in the sense, your concepts, your theory, your understanding does not meet it is happening actually. Even there is no black magic of that kind. There is no something like that games which can cheat you and try to achieve of that kind actually. They are happening, all the phenomena are happening with some hindrance. May not be visible for you through the naked eye, may not be visible for us to the visible radiation actually. Certainly something is happening. That's why, for example, if I hold a hand in front of a visible light, I can't see anything inside my hand, only flesh and blood and bones of that kind. If I allow the X-rays to pass through, of course, certainly they will pass through and interact. I can't fail. You are also not failing. But if they take an X-ray spectrum, X-ray imagery, or maybe X-ray film, which is developed, certainly they can see that the shape and structure of my hands with bones and pressures and other things. If there are any crack and other things, they can identify. Because the earlier experiment was done by the Ronson actually. Okay, what I was telling about in this context is that where Earth is flat, no doubt. It was a long back when the scientific community has expected. At that time, the kingdom was there. Kings were ruling the entire territory of course, depending on their domain or regime or their destiny of that kind. When they gave a theory that Earth is spherical, that scientist was hanged, not listening to the king, not listening to the people of the country, people of the soil, people of the land. That is the greatest and the hectic penalty in life for a scientific community which was happened before Second World War. What I want to say is that, see, people are in the Nimas, people, of course, with some neurological effect is different. People are as looks like a man because their theory, their concepts differs from the rest of the world. Scientific community also thinks in the same way. Being a physicist, of course, you are already the verge of the completion of the second semester. No doubt, hardly and one more year for you to be the master in physics. Okay, with that mastering, you have to be in a position to give explanation, to give the description, to give the reasoning for any kind of a phenomena which are happening through proper understanding, through proper learning. Okay, fine. It wasn't that. It was only to motivate you or to encourage you to do that, to join this. They have joined, they have narrated. Mossbauer fame means the name and fame they can call, grew immensely in 1960 because of this 58 experiment in Harvard physicist Robert Pond and the Glenn Repka shoes you can call the same thing, Glenn Repka used this effect to prove the redshift of gamma radiation in the gravitational field of the Earth. Redshift of the gamma radiation in the sense, okay, in the sense, if you allow the radiation to pass through from source to the spheres, if there is a massive objects anywhere in between, and these massive objects attracts due to the gravitational force. Radiation also got absorbed. Gamma radiation also got absorbed. That is the pulling of the radiation. Means how that gravitational influence field of the Earth is attracted. And if it is moving towards us is the red shift. If it moves away from us, is a different shift. A different shift of the kind. Means if it is moving towards us, if it is coming towards the source, is called the red shift. If it is moving away from the source, it is called different shift of that kind. Pond-Rebka experiment was one of the first experimental precision test of Albert Einstein's general theory of relativity. What Einstein gave, any two massive objects in the universe, either maybe at the level of the atoms or maybe at the level of the celestial bodies of two different stars, or maybe planets or star and planet, or maybe giant nebulae or supernova of that kind will be under the gravitational influence. Even no exception for the electromagnetic radiation. If the light coming from any of the star certainly gets blinded towards the gravitational influence of the celestial object and makes the curvature, inward curvature, celestial bodies acts like a convex lens. Means that is the if the object lies between the source and you, certainly the radiation gets concentrated towards you. That's what's happening during eclipse, during solar eclipse. If the moon is coming in between the sun and the earth, actually, you may be observing the coronal effect. That's true, but the radiation gets concentrated. That is one of the reasons actually don't see the sun when it is eclipsed. Means to say that if for eclipse, you may be thinking that entire eclipse will happen. But if it happens like a ring, actually, the radiations will pierce through, penetrate through the atmosphere. That is the shift known as the red shift. Red shift is a great shift, actually. In his theory, that is Einstein's theory, during 1905, Einstein had predicted that photons are affected by gravitational field, even though they are massless, even though their mass is zero, and therefore an electromagnetic wave should experience a change in frequency, no doubt, as it passes nearby a massive body. This is the frequency of the light, frequency of the wave, electromagnetic wave, whatever it should be, if it undergoes an interactions with the heavier body, need not be physically to a great extent, that frequency gets modified. Therefore, astronomical tests to observe the radiation coming from any of the stars or the sources, for example, has been previously devised to check this prediction. But these tests tend to be difficult in procedure and imprecise in their results. We can't expect to a great extent. Okay, there are some measures, there are some calculations, there are some ways to do that. The long-term importance of the Mossbauer effect, however, is its use in Mossbauer spectroscopy. Means understanding the red shift, understanding the isomer shift, understanding rest of them. Along with Robert Hertzfeld, Rudolf Mossbauer was awarded the Nobel Prize in Physics. Both of them shared 50% each to a great extent. Later life, just for you, on the suggestions of Richard Feynman, where you are fond of the Feynman lecture series, where you might have heard that the series of the Feynman lecture series, book 1, 2, volume 1, 2, 3 of that kind, Mossbauer was invited during 1960 to the Caltech University as a research fellow. Then he promoted within no time as a senior research fellow. SRF is senior research fellow, to make it single line. I truncated, don't worry. He was appointed as a full-fledged professor of physics in early 1962. Remember, he born in 29, almost 30. At the age of 33, he became a professor, full professor, they will call from the western side. In physics department, all are professors. You should feel more happy that all the faculty who are at the level of the professors are teaching you the subject in a greater way. It is not easier to get the education in India. I'm not clapping with all difficulties, with all your economical background, with all your efforts and other things, with the dedication of your parents, guardians, and your family members. They are sending you to the university by putting their efforts and even contributing the money for you for your educations. Don't waste. Make use of the time properly. Make use of the time. Make use of the department. Make use of the library. Make use of the faculty for learning. Try to get something when you leave this department to be a great extent. You should be none other than a physicist of any kind across the world. Uncomfortable with that. You should not feel shy. You should not feel hesitate. You should not tell utterly word that you don't have an opportunity to get the job in the market in the sense society. You will become a faculty, you will become a researcher, you will become whatever you want, even maybe administrative jobs, that doesn't matter. He became this senior research fellow within very short notice, and he was appointed as a full professor of the physics in the early 1962. But in 1964, this old university, technical university, where he was graduated actually, they called him and offered a professor post for him, actually joined as a full professor and retired as a professor emeritus in 1997. Almost, it doesn't matter, 97 plus 30, almost 58 years of service. It is not a big game to a great extent. In 1972, Rudolf Mossbauer went to the Grand Bowl to succeed in his Leibniz as a director. In 72, he went to that. I introduced you and with one of the institution, no? There he worked with the Leibniz, under the Leibniz for his PhD program. And he joined in 1972 as a director of the Institute Laurel Maine. Rudolf Mossbauer passed away on 14th September 2021 at the age of 22. A great contribution from a man, human being, from 30 to 80, 50, 52, 53 years, 53 years, what you can call, sorry, what you can call, at the age of the 82 actually, maybe almost about 50 years of contribution after he attained his graduation. That's a great achievement. by him, and a legend of the 20th century, a legend of the 20th century, actually, one among the legends. Several legends are there. That's why we are learning it to a great extent. This experiment became a landmark experiment. Let us go on to this. Sorry. Okay. What is the theory behind mass spectroscopy? Maybe either you can explain in your own way, okay, but you can keep it this as the reference. Immediate after this class, I will share these slides for you actually. Rudolf Mossbauer in 1958 discovered the recoil-free emission and absorption of gamma rays by nucleus. Means when gamma radiation interacts with the nuclei, those two nuclei should absorb the same energy. Nuclei should be in the same state, same energy state of that kind. If they recoil-free emission in the sense, that I will explain in the bottom one. So one of the schematic representations. Just go through the text fine. At the time, it was thought impossible for nuclei to absorb and emit the gamma rays resonantly, because they were aware of it that actually atoms absorbs and re-emit energy back. There may be a possibility of the resonance, means resonance in the atoms. Atomic spectroscopy was well known among them actually. Even 1958 they can call. It is not so long back actually. 40 plus 23, 75 years of that kind. 40 plus 75 years of that kind. Okay, the people were not aware of the nuclear interactions, and making the two nuclei in the same state, same energy state, it is a tough task. It is not keeping. I can't keep you in classroom for more than 1 hour. If I teach for more than 1 hour, or if faculty teaches for more than 1 hour, you will try to start making an agitation such a way that you want to go out. I'm not saying that interest, it's difficult for us. We are not habitual to sit at a place and work for hours together. How can you keep the atoms in the same state for quite longer duration? Maybe few seconds, or maybe few seconds to a great extent, even after a few milliseconds. Okay, it was believed that due to the conservation of the momentum gets conserved. That is the energy which is transferred by the incoming particle and interacting with the matter, and afterwards what will happen before interaction, after interactions, energy should be conserved, momentum conserved, force should be conserved, mass should be conserved, everything should be conserved. The emitting and absorbing nuclei, this is the one emitting nuclei, one A nuclei A, and the absorbing nuclei would lose some of the gamma ray energy by recoiling, therefore eliminating any chance of the gamma ray being absorbed again by another nucleus. This due to very narrow line width of the some nuclear energy levels. Due to their long lifetime, the uncertainty principle exists. Means to say that what happens actually, see here, read in such a way, absorbing nuclei would lose some of the energy. So you are supplying the energy. A nucleus which absorbs that energy through the gamma radiation by recoiling. It absorbs and emits the radiation back in the gamma photon, okay, with some energy, x minus delta x. That delta x should be the recoil energy. A simple way. For example, if you are supplying some 10 joules of energy, 8 joules will go for the photons and emitting photon or ejected photons. That 2 joules will be absorbed by the nuclei, and it will go with a different kinetic energy because of the momentum. That energy is known as the recoil energy. What he says is that due to the short, very narrow line width you are getting, about energy wavelength of the order of about some 200, but some 100 keV or 150 keV energy, very short line of that kind. If it is a broad spectrum, it is a difficult task. Because of that energy levels, due to their longer lifetime, uncertainty principle existed. Delta E and delta T should be of the order of H cross. Remember, delta E times delta T should be of the order of H cross. If delta E is very short, T should be the long. Means if you are precise in making measurement of the energy, you are losing the time and time gets delayed. In 1958, however, Mossbauer showed that if the absorber and emitting atoms are embedded in a lattice, how can you embed it? Let us take one lattice crystal, or crystal lattice they can call. You might have seen that sodium iodide crystal, sodium chloride crystal, or potassium iodide, KCl, NaCl, those structures you might have seen that. Like a cube, in the corner of the cube, atoms will be there. Maybe simultaneously one sodium atom and another chlorine atom of that kind. Maybe if you take the entire lattice, it will be well structured. Either sodium, potassium, whichever maybe the one you can take actually. How that what they are saying that actually here. If the observer and the emitting atoms are embedded in a lattice, that is the quantum mechanical perspective of a solid, The recoil due to the gamma ray may in fact be taken up by the entire solid, making the energy loss negligible. It is a brilliant idea. Means to say that instead of two individual separated, or maybe you can call it as an separate nuclei, isolated nuclei, then you can have the interactions that may not happen. For example, what I want to say that take a ball and hit a ball with another ball. What will happen? Being the case actually, a ball, whatever you are throwing, will carry energy. If it hits a stationary ball will also move in one direction with recoil, and a ball you hit will also move. The ball you are, the earlier ball, the what you hit it actually, bombarded ball, will move with an energy lesser than the energy what it carries. The difference will be carried out by the recoil. Or do one thing. Take a ball, keep some 10 balls in a box. Okay, keep 10 balls in a box. Okay, leave the throw that ball. Still there is a possibility that some of the ball, or maybe single ball, if it hits, for example, that may carry energy will come out of it with recoil. What it is says, even if it comes out of it, actually there should be a recoil energy. There is no resonance. Take a well packed ball, a box of ball. Okay, like the one maybe about 10 or 20 balls are packed well. Okay, you hit that pack of balls with a ball. Okay, the ball has to hit a single ball in a pack. What will happen? The bombarded ball will come back with some energy. Okay, but the pack, whatever you are expecting, will not move at all because of the heavier mass. Since if you hit a ball to a wall will not move. Maybe small energy will be, a recoil energy will be there. You may not feel at all. If you hit a ball to the earth will never bounce back to a great extent. Means ball will bounce. That recoil energy. What he thought is that keep that target in a heavier mass. Okay, target should be higher Z values of higher mass, larger dimension also, where the energy will not be exchanged. If we are making the two nuclei in the same energy states by some level that they have shown in the right bottom corner here, actually, okay, certainly the energy emitted will match with the energy absorbed. Whatever the energy gets absorbed will be released back, because you are supplying energy from the ground state nuclei. Nuclear excited state will come back, and the ground level nuclei will absorb and go to the excited state. This comes back again, excited will release. This photon and that photon is having a same wavelength or of same frequency, not similar frequency. It is of same wavelength and same frequency. There will be a resonance, you can call. That resonance happens, nuclear resonance happens by what we can call non-recoil, or maybe recoil free or recoillessness of the nuclei. This is in fact very essence of mass spectroscopy, discovery of recoil free nuclear resonance emission and absorption. We'll see the Mossbauer effect, how it can go with that. The Mossbauer effect states that when some atoms are held tightly in crystalline atomic structures, the gamma radiation emitted by their nuclei are very close to being recoil free. Means that is, by being recoil free, there is no absorption of the energy by the atom or the nuclei of an atom. Okay. Certainly the energy which is emitted and energy which is absorbed should be the same. This implies that emitted photon has the exact frequency that corresponds to the transition energy between the nuclear ground state and the excited state. When this photon carrying the full nuclear transition energy strikes another similar nucleus also embedded in a tight crystalline structure, absorption may occur. Because the nuclear energy levels are very sharply defined, only such a photon, one that carries the exact transition energy, may excite another nucleus. Of course, only if the observer does not recoil. A simple schematic is shown here. Okay? What we are getting out of it actually? Okay, it causes or it leads to the very narrowly defined nuclear energy state. The smallest change in the nuclear energy of the photon will destroy the resonance. Even there is a small difference in the energy that destroys the resonance. Thanks to this extreme sensitivity of this experiment, because of this extreme sensitivity, mass spectroscopy has proven itself an excellent method to measure. Otherwise, it is impossible to detect the nuclear energy differences among the nucleons in a nucleus. Therefore, either minimal energy or minor energy variations, magnetic field at the nucleus, and even distortions or asymmetries in the shape of the lattice that encloses the atom are enough to produce the shift, red shift, and splittings in the absorption lines. All these alterations or modifications of the nuclear environment that produce an observable effect are called nuclear hyperfine interactions. This is the beauty. This is the only thing. This is maybe the first slide for you. Actually, doesn't matter. This is the thing. Of course, theory you can develop, no doubt. I will go on one to other. How that must for hyperfine structure or hyperfine interactions can happen actually. Just see that. Don't worry with the length of the text. The Mossbauer effect is a nuclear phenomenon, no doubt, which is related to the emission and absorption of gamma rays by atomic nuclei in solid state lattice. Therefore, the experiment which involves the interaction of gamma rays with specific atomic nuclei, if you take, usually those of certain isotopes, usually iron is taken to a greater extent, okay, in a solid material. Here there are some key components and principles of the Mossbauer effect. We'll go one by one. One is the recoilless emission and absorption. When a nucleus emits or absorbs the ray, gamma ray, it is typically experiences a recoil due to the conservation of momentum. In most cases, recoil energy is significant to cause the measurable shift in energy of emitted or absorbed gamma rays. However, in Mossbauer effect, there is no recoil energy or recoil energy is negligible due to the perfect lattice structure of the solid. This we had choose such type of a solids for the experiment, allowing the process to occur without the energy loss. It leads with the Doppler shift. It leads with the nuclear resonance. It leads with the isomer shift. Being a Doppler shift, what happens actually? A Doppler shift is a shift. Whenever the interactions can happen between the two, we would like to estimate that the shift should be a positive or negative shift, should be a red shift or maybe a blue shift of that kind. Okay. Even though the recoil energy is minimal, the gamma rays can still experience a slight Doppler shift in energy if they emitting or absorbing the nucleus in motion. Okay, that's why whether the nucleus is approaching the target, the nucleus is approaching, that is the target is approaching the bombarded electromagnetic radiation or moving away. Okay, red shift and blue shift are one of the shifts actually. We can have Doppler shifts they can call. There should be resonance, no problem. Here you remember that nuclear resonance, certain atomic nuclei have a specified energy levels that can be excited by the gamma rays. When the emitted gamma ray has an energy that corresponds exactly to the energy difference between the two nuclear states, nuclear resonance occurs. This results in a sharp peak in the gamma ray absorption spectrum. Of course, that we can observe. There is a possibility that isomer shift, the energy means if you hit with the iron, if you hit an iron, cobalt becomes iron. Cobalt becomes iron it by losing an electron. By losing an electron, the energy of the gamma rays can further be influenced by the electronic environment of the emitting or absorbing nucleus. The distribution of electrons around the nucleus affected the local electric field and modifies the gamma ray energy. By careful analysis of the emitted and the nuclear gamma rays, we get a valuable information about the nuclear properties, electronic structure of an atom, and lattice environment of the material, whichever we are using it for the study. The Mossbauer effect has been instrumental in various scientific fields, including solid state physics, chemistry, material science, physics, astrophysics, and that kind. Yeah, here you note down, this is the hyperfine structures. This is the illustrations they have given. This is the observed spectrum. See that in one of the isomer shift, what happens? It goes down and comes up. This loss you can expect. It is measured between the two energy levels, between the source and the observer. It is explained. Zeeman effect, for example, there should be a shift in the peak actually. You can go with the isomer number in such a way, I 1 by 2 to 3 by 2 shift can happen between any of the energy levels. This shift through the Zeeman effect, you can expect the magnetic dipole splitting of these lines. The quadrupole splitting can also happen with the same case. See that you can expect that quadrupole shift in the frequency or the wavelength. See that how that they observe this with the Mossbauer absorption spectrum. The spectrum looks like that. Whenever you are getting a resonance, certainly there will be a drop, maybe a drop again, drop again, drop again of that kind. This is in terms of the velocity. Either towards left is negative shift, it is towards path. Whether source is moving towards path, towards the source and detector are approaching each other, or whether they are moving away from that. Both will also be taken into the account. Here, why Mossbauer spectroscopy is so much interested is mainly because of the gamma ray spectroscopy. And earlier to that, Recoil in 1929 worked out actually, but this is first observed by the in 1958 by Mossbauer. Why it is difficult? Because getting gamma radiations with the excited state is a difficult task. See that here what happens, nucleus emits, it absorbs. When it absorbs the energy, that is why down. When it emits, it should go up. Then we can detect. Recoil energy can feel in such a way that this beautiful candidate is holding a gun where if the bullets are shot out of the gun, a gun recoils. This should not happen actually. Why recoiling happen? It absorbs, there should be an energy state between these two. What happens is that it is the emission spectra, this is the absorption spectra. This E gamma minus ER should be the emission spectra, loss of energy. That should be estimated by the following equation. Here there should be an absorption, you can have the expectation of that kind. If not, what will happen in Mossbauer is that this energy, what you are expecting, ground state to the higher energy state, it emits with the recoil. Okay, if not, this recoil will be bounce back. See that this is the Mossbauer, that is the loss with the Doppler shift, because one kind of a blue shift and a red shift, and if they are merging, this is the thing what can happen. Some energy levels you can estimate by making use of this. They can also be seen in such a way that nuclear decay schemes in such a way for iron. Iron is the most abundant sample they have used actually. Comes with this energy. This is about 270 days half-life. This comes with the 136, but or directly it come back to the iron, cobalt to the iron, or it may go with the intermediate stage about 85% with the metastable state about 100 with the longer duration. Okay, and here within 100 nanoseconds it will jump from this state to this stage. Why it is mostly used? Because of the half-life, and 90% of Fe57 star, what you are expecting, decays to the ground state directly with the emission of the gamma photons, and 91% what you are expecting, it is different. Here conditions for the Mossbauer is in such a way, these conditions we have written, what we are expecting here. What happened? Sorry. We'll lie with one slide. This is the last one, where we are using these applications of the Mossbauer effect. Investigation of chemical and physical properties of materials, no doubt. This Mossbauer effect allows researchers to study the structural and electronic properties of the material at the atomic level, giving or raising this to the characterization of the substances and understanding their behavior, even determination of the oxidation states and coordinate environments, maybe by studying the transition metal compounds or their oxidation states, coordination environments, the chemistry part of it. Analysis of minerals and geological samples. It is used in geology to analyze and identify minerals and their variations in different geological samples. It's used in astrophysical research. Particularly, spectroscopy has been employed in the analysis of cosmic rays or cosmic gamma rays and in understanding the nuclear processes which are involved in it. This also used in atomic and nuclear physics, provides a precise measurement of the energy states or energy transitions in atomic nuclei, contributing to our understanding of the quantized nature of energy levels in atomic systems. In condensed matter physics, enables us to study these atomic and molecular vibrations in solids, which are unprecedented with precision, with high precision. By investigating how gamma ray interact with the solid materials, scientists gained a valuable insights into the properties condensed matter, such as lattice vibrations and their behavior of phonons. Doppler effect and relativity is an evidence for that from the Mossbauer experiment. Mossbauer experiment confirmed that validity of the Doppler effect in nuclear transitions and most significantly provided an experimental evidence of supporting Einstein's special theory of relativity. General theory of relativity is a different case actually, of course. Einstein's special theory of relativity. This aspect of experiment has implications for understanding of time dilation and gravitational shift. That is why space and time, it does not work with only other things. Space and time is a phenomena. Whenever there is a gravitational influence which acts, space gets disturbed because of the time dilation. Is also used in technological applications like precise determination of isotope shift and nuclear parameters. This isotope shift I mentioned here, this this isotope shift actually, isomer shift and isotope shift, you can expect actually shift of one element to another element actually. Shift of one element to another element can also be observed actually. This is a beautiful experiment and there are a lot of applications among this. I will try to stop at this moment. If there are any queries, I can address or we will take the class in rest of them. Try to read this as much as possible. I will share the two videos and also the material one in PPT to you very soon. Thank you. Thank you for your patience and your listening.